Hi there, my name is Sinan and I'm a flame artist from Turkey, now working at Flamberg, a production company in Oslo, Norway. In this video series, I will try to demystify Flame's particle system. But before we dive in, I would like to thank Autodesk for sponsoring this video. Welcome to Logik Academy. The particle system in Flame can be accessed through the action module. It is a group of nodes that we can use to generate, animate, and bounce particles as needed. When we want to create a particle system, first we need a generator. This is sometimes a light, sometimes a surface, and sometimes a geometry. I'll start with light now. When we add a light to the scene, the shading and rendering are automatically activated. So when we add a particle generator and look at the result, we won't be seeing any particles. To see the particles properly, we need to turn off shading and maybe even rendering of this light. Going to the first frame and pressing play, we see all the particles being generated in all directions. The spread of the light cone will affect where the particles are looking at or where the particles are generated towards. So playing around with the spread parameter will limit the particles to a specific cone. The particles generated here are lines. To see some of the effect of the parameters, I'm going to turn them into square particles. The number tells us how many particles are being generated in each frame. So I'll keep it at 10 and add a variance of 5. So there will be between 5 and 15 particles generated per frame. The lifetime parameter is one of the most important ones. It tells the system how long each particle is going to live for. So if we add a variance of 25, some of them are going to die sooner and some of them are going to live for a little more while. The size parameter will adjust the size of each particle with its variance. There are going to be bigger and smaller particles in the system. If we take this to 10, you will see the effect better. So there are smaller and larger particles. Same goes with the speed. The speed parameter affects the initial speed of the particles, where the variance adds some variance to the speed. So some of them are faster and some of them are smaller. Let's take a look at the type of particles. We just saw lines and squares. The simplest one is points, and they are dimensionless particles that can be used for small things like dust or some atmospheric effects. Lines are rendered as lines. Their length is affected by the speed parameter. So if we turn the speed up, the particles look longer. Square particles are basically like point particles, but they are 2D squares that always point at the camera, but their orientation can be changed with additional parameters in the second tab here. We can add textures to the square particles. Same with the quads. Quads are 2D particles, and like lines, they will point at the direction they're traveling in. The size for the quads will adjust their width rather than their tail. Like the line particles, the speed parameter is going to affect their tail length. Spheres are basically primitive sphere particles. They don't look in the direction that they're moving in. Like the squares and points, they are irrelevant of their speed or orientation. Like points and squares, they do not turn in the direction they're moving in. The shading is currently off, but I will keep it off for the time being. Cones are also like quads and lines in the sense that their speed affects their tail length, like you see here. But of course, making them bigger will make more thick 3D particles. When using the external node, we can use a geometry, a 3D text, or a surface with some internal animation, and all the particles will be replaced by this external node. Let me start fresh by trying to create a real-life particle system using these simple parameters. I will use a light as my emitter source. I will make it look up and I will pull it over here. Adding a particle generator. Remember to turn the active and shading off so we see the particles. I will make them squares, make their lifetime longer so they travel far. I will make their speed to be 25 and variance to be 5. So we will see a stream of particles moving up. We can, of course, keyframe these parameters. I will generate 25 particles in the first frame and turn that number to 0 on the third frame, so we have a boost of particles. Now if we add a particle animator and tell this one to be gravity, because of the hierarchical links, the gravity is pointing downwards, but I want that to be a free axis. I want to turn it down, so rotate it 90 degrees on the x-axis. And when I press play, the gravity doesn't seem to work. That's because the force is affecting the position of the particles. This only works for the first frame of the generation. When I change it to speed, you will see them going down. This is more or less what I'm looking for in a confetti bomb, let's say. The gravity is pulling them down, but I want to start the particles to be a little faster, so they travel some more up there. Now, if we want to slow them down, we can turn the damp button on. I will damp them both, not size or mass. Damp both will work okay for me. And when we press play, we see that they reach a maximum speed and then they slow down. By playing around with these parameters, you can change the behavior of the particles. I think a value of 15 or 10 will be good. The gravity is still affecting them, but the damping, when turned on, gives them a maximum speed of 100 pixels per frame. Let's make the particles a little bit bigger so we can see them better in the frame. Did you notice that they are now slower the bigger I made them? Because that's the damping working on their size. I will take this down back to 25. They are still a little bit too slow, so I can maybe change this to damp mass and not their size. So their size doesn't affect the slowing down. This looks sort of good. To add another layer of animation, I am going to rotate or spin the particles with a variance of 10 on each frame. Now remember to go back to the first frame and generate your stream again, because after you change some of the parameters, the system needs to restart. There, we have a nice looking confetti bomb. Now if we go into the particles color variation and say 200 here, go back, now we have colorful particles. There you go, a simple confetti setup. Some of you may have watched Apple's iPhone event, so I'm going to try to recreate the effect that they used before the beginning of the event with the starfield and the Apple logo. For this, I'm going to start with a clean action, and I need a color source as the generator, and I will use another color source, but this time as a color noise. Okay, so once we have the surface, now I'm going to use this color noise to actually displace the first one. I'm going to mux this so it doesn't animate, and I'm just going to make this smaller so we can see the effect. And displace it. There. This will create a volume, because if we look from the top or the side, we can see that the displacement map is creating a volume. I will set the displacement to 2000. Let's make this 200 times. Look at the camera. I need to push this somewhat back, and now I'm going to hide this. And here goes our particle generator connected to the surface, which is displaced now, so it's almost like a volume. I'm going to create 5,000 particles in the first frame and then 0 particles. So I will have just 5,000 stars. Their lifetime should be like 1,000 frames, or let's say 500, and their speed should be 0. They should be standing still, and they should be squares. The size of 10 is good, but I'm going to add a variance of 4. Again, we have to go back to see the full effect, to see the generation. In the animation, Apple did like a camera move, so I'm going to parent an axis to the camera that's going to be looking from the top, so I can move it without moving the camera. What I want to do is actually rotate the camera around the whole scene. I'm going to start with -75, and in like 250 frames in 10 seconds, go to 0, and we have a nice animation. I'm going to animate I'm going to fine-tune the animation curves in a little while, but this looks already good. Let's give our stars some texture. I'm just going to use this one, and the particle generator wants to have a diffuse map. There you go, a starfield. It still needs some work, but we're almost there. Well, Apple used its own logo to go through, but I will use the Logik logo. This is going to be our particle generator for the stars that will form the logo. Let's add it to the scene. Well, the proper way to look at it is going to be on the 250th frame. I'll just unparent the rotating axis. I want to generate the stars that's going to form the logo through the outline of the Logik logo, but I want them to be displaced or distributed over the Z dimension as well. So I will also add another displacement map to the logo. Displacement map. And when I do the displace, the surface is displaced, but the displaced vertices are moving out of the frame. If we look at this from the top, you can see that it's displacing the vertices on only the Z direction, but we can do a camera displace, and the displacement does take place, but it moves towards the camera, so there's actually nothing to compensate for. Flat displace, camera displace. This gives me everything that I need. Now I want to generate another set of particles from the logo itself, particle generator, and the type will also be similar to this one. I just like to pull them together. So these are going to be square particles as well. I want to have 25 for size, nope, 25, and the variance of 10. The speed should be 0. Their lifetime should be 500. And I'm going to generate 100, and I'm going to generate 100 particles per frame, but I'm going to fade them in and out, so these lights are flickering a little bit, not like the star background. And let's see what we have here. Yes, this looks nice. And when we rotate the camera, we can see that the stars point the surface that's been displaced, generating the Logik logo, is looking towards the camera. Let's attach our axis that was rotating the whole system. Now, I think there is going to be a problem here. Let's see. Yes. This is because the displacement map creating the particles is always pointing at the camera. So while we rotate the camera, the displacement also rotates. There is a quite easy fix for this. I can duplicate the camera and I'm going to name it displace me. And if I go to the displacement map, it's still set to camera displace, but not to the result cam, but displace me cam. Now if I look at it from the top, there, it's fixed. Result, I will hide the surface that's generating the particles. And there we go, Logik. The 250th frame, I will set this to be 0. And let's say on the 500th frame, I'm going to take this way back. Let's see if this works. Nice. Now the particles are a bit too big. Let me make some corrections to this system. The particles that form the Logik logo, I want to add a fade in, fade out to them. I say it should be a function and it's the transparency equals sine lifetime, sine parentheses, lifetime I. This lifetime I is the individual lifetime of each particle. So when it is born, it's at 1. When it dies, it's at 0. I have to multiply this by the pi. So because the sine function works with radians instead of degrees, so this function will fade the particles in and out over their lifetimes. So they won't pop in or pop out when they are generated or when they are dead. I only have an issue with the logo particles, that when the camera moves through them, they are too big. I have an idea to solve this, but it needs some mathematics. This particle animator is going to be a function. This function is going to define the size of the particles depending on their position relative to the camera. How are we going to do that? Well, for this specific case, I more or less know where the camera is, because when I look at it from the top, when the camera is moving through the particles, it's actually moving only in the Z direction and the axis moves it. So I know how to calculate the exact position of the camera's body, right? It's the Z position of the camera minus the Z position of this axis. So if I want to calculate the distance between the camera's position and the particle's position, let's say over here, I can write a smooth step function. The smooth step function checks for a specific value, and if the result of that value is lower than the defined minimum, it returns 0. If it's larger than the maximum, it returns a 1 and makes a smooth transition between the two values. So here comes the mathematics part. First, let me add another axis. And this axis will have its position z. So the position of this axis is going to be the sum of these two. Let's write the function default position z plus axis 3 position z. Now if we look from the top, this axis that I linked is moving towards with the camera's z position. And if we look from the top, the z position of this axis is actually moving through the particles. So I know where the camera is in the scene. Now I'm going to link this value, the z value, to the particle animators, to one of the parameters of the particle animator. I'm going to link it to magnitude. Copy channel and link it here. Now the function becomes, I want the size of the particle to be size multiplied by the smooth step, which of course going to give me 1 or 0 or some value in between. To define the minimum and maximum values, I'm also going to use the parameters from this particle animator, the min speed, comma, max speed, comma, and the length between the position 0, 0, magnitude, which is where the camera is, minus position. This pos is the position of each individual particle. I'm going to close the parentheses twice, I guess, and enter. Now let's see if this works. The particles should get closer, the particles should get smaller as the camera gets near them. It didn't work. It didn't work because we didn't define what minimum and maximum values are. Let's say the minimum should be 50 and the maximum should be 1000. At 1000, so if the camera is 1000 pixels or units away from the star, the particle is not going to change, but if it gets any closer, it will start to dwindle in size. I changed the maximum value to 500. So they get smaller and smaller. I think there is a problem with Z buffering. I will mitigate that problem by turning off Z buffer. the particle generator. Particles should be sorted, and these should be sorted, and no preferences. I'm going to turn Z buffer off. Let's see it from the start. There is no flickering now. And my particles get smaller and smaller. There you go. A star field with Logik logo forming. And we fly through them. And while we fly through them, the particles get smaller. Now, in the first couple of samples, we used a light source as an emitter and a surface as an emitter to achieve simple effects. The most common use of particle animation is to create a flow of particles, and to control the flow of the particles, you usually want to affect their position or their speed. Now, someone said like 20 years ago, doing a particle animation is like training a flea circus. You set them free and you hope that they get there. So we're going to try to set them free and hope they get there. We're going to create a square as our emitter. This is going to be a generic explanation of the turbulence function. Now, when we look at the particle generator from the front, the surface is obstructing our view. I'm going to make this fully transparent so that we can see the particles clearly. Let's make the particle emitter a bit smaller, and I'm going to turn up the number of particles per frame as well as their lifetime. Now the animation is set to 250 frames, but I'm going to make this like a 10,000 frame animation. It's just because while we run the animation, you can control its flow with interactively playing with the parameters that we're going to add now. Okay, here comes the particle animator. This is a function, and functions usually are used to adjust the position, speed, transparency, and the color of the particles, as well as their size. I am going to show you how to adjust the speed and the overall flow. So the first function that I'm going to write is speed is going to be equal to the speed, of course, from the previous frame, plus a turbulence function, which should be a vector because speed is a vector, turbulence 3, and it needs a seed, which I am going to put in as pos, which is the position of the individual particles, and an octave number, which is 1. Now, when we look at this animation, especially from the side, we see that they're getting turbulent in a short while. So the turbulence function or the turbulence pattern is too dense. I want to make that turbulence function wider so we can see the tendrils of the turbulence. Now I know that multiplying it by 0.01 or dividing it by 100 makes a good visualization of this. Now you can see the flow in wider tendrils. Look at it from the front. Now this, since it's an addition to the original speed or the previous speed, maybe it would make sense if we multiply this value by 0.93, for example. So although the speed is tuned down like 7% each frame, the turbulence value we add here makes them still move in the positive direction. You see now they are slowed down and some of them are even turning back. Of course, it's not really elegant to enter a manual value here. So instead of doing that, I am going to multiply this by 0.01 and multiply it again with the minimum speed value here, which goes from 1 to 100. So when it's multiplied by 0.01, it will still give me almost the same pattern. Remember to make the S capital. I'm just going to get this into a parenthesis so it's easier to see. So I am multiplying the speed with the minimum speed parameter here, which let's say keep it at 100, and we're dividing it by 100, and it's the original speed. So when we make this 93, the same pattern will continue to flow. The advantage of doing this is you can manually play with the minimum speed parameter and see the result interactively in the viewport while you're pressing play. That's why we made this 100,000 frames or 10,000 frames. Okay, 93% is usually a good number. Another thing that you can realize is the turbulence pattern is sort of static. So we need to introduce some sort of constantly changing value to animate this turbulence pattern. And to do that, I am going to add another plus sign here. So this is going to be position plus, needs to be a vector. So a vector is x, y, and z components. I'm writing frame as the z component here because the frame number always changes. When we press play, we can see that the turbulence function is now actually changing slowly. To add another control parameter to this one, you can also multiply this with the magnitude. So when you animate the magnitude, you can see that the turbulence function is changing drastically. But when you set it to a static number, it continues to evolve smoothly. How about changing the size of the tendrils now? You remember that we multiplied this with 0.01. So if we add another multiplication here and add the power variable from the parameter box here, and if you animate the power, you can see the density of the turbulence changing. Now between 0.1 and 2 or 3 are usually good numbers. The lower you pull the power down, the bigger the tendrils or bigger the pattern will be. So by interactively playing with the numbers here, you can use this turbulence function to modify any flow. I'm going to look at this from the front. Let's keep this as is, and let's make a copy of this. Let's make 2 copies of this. Okay. For the first one, I'm going to rotate the emitter 90 degrees on the x-axis, make it a tad smaller, and take it down. And when we press play, this almost feels like smoke. But to make it more feel like smoke, we could try playing around with the initial speed of the particles so they move up faster. To adjust the speed of the particles moving up, we can add another particle animator. Call this to be a transform function or a transform animator. Adjust the speed of the particles, and when we press play, they're probably going to fly away. That's because the axis of the transform modifier needs to be free from the hierarchy because it also takes in the positional data. So when we press play, actually nothing is changing, but when we adjust the Y parameter to be 1. They are pulled up. Let's make this 0.25, so it's like a really small value. Okay, and we can go into the particle animator and also play around with their speeds, making the slowdown 3% or 93, as I always say, is a good number, and the size of the turbulence pattern can be adjusted here. One more thing maybe we can add to this is another particle animator, and that's going to be a function again, and we're going to adjust the transparency of the particles set to their lifetime I variable. The lifetime I variable is lifetime of each particle. Their transparency is 1 when they're born and 0 when they're dead. So there is like a linear fade off to the transparency of the particles. A simple smoke. Well, you could add trails to each particle with a variance of 3 maybe, and they will look more like continuous trails. You could maybe sort them so that they're not overdrawn each other, and the number could even be lower because we added trails, maybe even 20. You could try adding motion blur or some other post effects down your flow graph. Remember, we made 2 copies of the same setup with the same particle animator as the function for the turbulence. We could try making another sort of example here. So let's say we create a text, and so when we press play, we're just going to see the Logik logo emitting particles. Let's create even more particles, because when you use a matte for your surface, the total number of particles considers that the entire surface emits particles. But when there is a matte, the total number of generated particles is much lower than the value you enter here. Let's add a particle animator, another one. Let's transform speed, and it should be free. Let's move the particles 0.4 pixels to the right and 0.7 pixels up direction. Now, since we can grunge this text or erode this text and make it look like there is like a title animation on the Logik logo being eroded away. Let's try to do that. Sorry, that took a little bit of time, but you get the idea. I'm melting or disintegrating the Logik logo. However you want to do it. I use crop grunge to grunge the matte. Of course, you can make these particles points and see them fly away into smaller bits. So here we showed the use of the turbulence function to create sort of a smoke and a dissolving logo.